We take the data as it is, okay, the same data. First, we have to prepare the document term matrix, okay, for doing this sentiment analysis. So import the packages. We will close the previous files. Open the sentiment analysis folder and then import the package, import the data set, use one single pre-processing function, pre-processing. Usually this pre-processing takes 4-5 minutes time. After that, create the word cloud. After that, create the document term matrix. So until here, we already discussed. What is it? It is the data preparation phase. So what do? We take the data, convert it into document term matrix. Now we are talking about, in this session now, from here on, we are going to talk about sentiment analysis. Once again, what is sentiment analysis? Given a tweet, given a document, whether it is positive tweet or negative tweet is what we are going to get there. Okay. Twitter sentiment analysis is what we are going to do. This is the final document term matrix that you have. I want to tell you one important information here. A lot of people have a misconception when it comes to sentiment analysis. A lot of people have this misconception and you should not have it. First of all, have you got the code file, all of you? Get this code file and keep it running in the background. Keep this executed until document term matrix. You keep it for execution. Until the document term matrix, keep it for execution. Okay. Now look at the important one. Let it execute. For me, it is still executing. Let it execute in the background. One important information here is, let's say if I am doing Twitter sentiment analysis, so I will have lots of tweets. Let's say my customer gives me tweets. First tweet, whether it is positive or negative. Second tweet, my model has to tell whether it is positive or negative. Third tweet is positive. Fourth tweet is negative. This is what my model has to tell. And I have this data, only tweets I have. If you have only tweets data, looking at each tweet, if our model has to tell whether it is positive or negative, it is not possible. Not possible. What you need to have is, or even reviews. Let's say if you have review 1, is it positive or negative? Review 2, is it positive or negative? Review 3, is it positive or negative? Directly building a model that will give you these predictions is not possible. What you need to do is, the data that we have should already have, it is review 1. This is like input X. And Y also should be there for building the model. What is Y? Tell me. Review 1 is positive. This is a positive document, positive review. Review 2 is a negative review. Review 3 is a positive review. Like that, for your data, you should already have which documents are positive, which documents are negative. Then you can build the model. If you already know what are positive, what are negative, what is the need of model, what is the use of model, tell me. Why are we building this model then? Already I have 5,000 reviews. Already I know which reviews are positive, which reviews are negative. What is the use of model? When the new
If
review
such
comes,
comment,
when the
yeah,
new review
if such,
comes, isn't it? What is model
yes,
building? Learning the patterns from here, isn't it? Put them in a model. When the new review comes, can the model now predict positive or negative? The model will
yes,
learn all the patterns from there, then predict it as positive or negative. So the mistake that a lot of people think when it comes to sentiment analysis, when it comes to numerical data, a lot of people expect target variable already. But when it comes to text data, this misconception is there that even without this, we will be able to build the model, but that is not possible. Will you be aware of it in future? If a client tells us that I do not have the target, is it possible to build a sentiment model on it? Sentiment analysis model? It's not possible. You need to have the tagged positive or negative, positive or negative, positive or negative already should be there. From there, we can build the model. First, convert this data into document term matrix. But the problem with document term matrix is, what is the problem with document term matrix? In general, document term matrix is very sparse. What do you mean by sparsity? What is being sparse? This matrix is very sparse. When do you call a matrix as very sparse?
More zeros
If there are
and
so
less
many zeros
information.
and lesser numbers are there, less information is there, that is a sparse matrix. Since this data is very sparse, not all models will work on this. Probabilistic model like Naïve Bayes model works much better on this. Naïve Bayes theorem, it comes from a theorem called Bayes theorem. Probability of AI given B equal to probability of B given AI into probability of AI divided by probability of B. This theorem, when you look at this formula, it looks very confusing. In reality, it is a very simple formula. When we understand this, you yourself will be saying this is such an easy formula. We will see the notations are somewhat a little confusing in the beginning. We will be understanding this with an example. Let us understand Bayes theorem. Using that Bayes theorem, how do we do this sentiment analysis model? Look at this. Imagine there is a factory. This is an example to understand Bayes theorem. Okay. To understand this formula, I'm giving this example. Please focus. Imagine there is a factory. There's a big factory. In that factory, we are building some nuts and bolts. These nuts and bolts are used in some aeroplanes. There are two machines in that factory, machine A1, machine A2. Machine A1 produces 60%. Machine A2 produces 40% of the nuts and bolts. A1 production, 60%, probability of A1, any bolt, probability of A2, 40%. A1 defect rate is 1%. Let B indicate the defect rate. A1 defect rate is 1%. A2 defect rate is 5%. What do you mean by defect rate? A1 defect rate is 1%. What does that mean?
There are,
Like
out of 100,
one will be
there
somewhat defective. You cannot use it in the aeroplane, like some threading or some length or something is wrong. That is the defect rate. Okay. Now, probability of B means defect. B means defect. Given A1. So B means defect. Probability of defect given machine is A1. Tell me how much is that? How much is that?
1%.
1%. Probability of defect. This is also defect only. But given the prior information, given the machine is A2, what is that? 5%.
5%.
This is given. When you give some prior information, probability changes. That's how you write like this. For example, what's the probability of Saturday? What's the probability of Saturday? You take any day. What's the probability that it's a Saturday? Overall events are how many in the denominator? What will be there? Denominator?
7.
7. It is 1 by 7. Do you agree? Yeah.
Yes.
Probability of Saturday is 1 by 7. Probability of Saturday given the prior information that it's a weekend. Given it's a weekend, what is the probability of Saturday?
1 by 2.
Given it's a weekend, which means there are only 2 days possibilities. And then what is the probability of Saturday? 1 by 2. See, this is also probability of Saturday. This is also probability of Saturday. But given prior information, probability changes. Have you now understood given, concept of given? Probability of Saturday given yesterday is Friday. What is the probability? What is the probability
Once.
of Saturday? Yesterday, if yesterday is Friday, what is the probability of Saturday?
Once.
We are
One.
sure that it is
You see
Saturday.
here,
Next day
one
is
by
Saturday.
one, isn't it? There's only one chance. So given the prior information, the probability changes. So prior information, the probability changes. Have you understood the concept of given now? Given A1, defect rate is 1%.
Yes, sir.
Given A2, defect rate is 5%. Now tell me, what is the overall defect rate? If I want to find the overall defect rate, simply can I add 1% plus 5%? 6% is the overall defect rate. Is that the right way to do?
No, sir.
Since A1, A2 are not producing the same amount, you cannot simply add them up. You have to take the weightage, isn't it? What
Yes, sir.
weightage you will give to this 1%? How much weightage? How much weightage you will give? 60%, isn't it? Look at this. A1 defect rate into A1 production. 1% into 60%. A2 defect rate into A2 production. Overall defect rate is not 1 plus 5, 6%. Overall defect rate is 2.6%. Do you think this formula is correct? Think about it. Overall defect rate is A1 defect into A1 production, A2 defect into A2 production. 1% into 6, 5% into 4, 0.026, 2.6%. Do you agree with this? Is this clear? Why 2.6% came here? Overall defect rate. We multiplied with the weightage of A1 production, weightage of A2 production. This is how the normal probability flows. All of us do understand this probability because in the denominator, all the events, in the numerator, favorable events. We all understand this probability. Bayes theorem or Bayes probability is also known as inverse probability theorem. It goes in the opposite direction. It goes from this side to this side. It's also known as inverse probability theorem. Imagine that you have a heap, huge heap. Look at this example. You have heap of nuts and bolts. You took one product. You took one product. It's already defective. I'm already telling this is defective. Now what Bayes theorem tells us is, given this is defective, because I have already given this is defective, can you backtrack and find out? Can you backtrack and find out? Complete the statement. What Bayes theorem tries to tell us? Given this is defective, can you find the probability of this coming from produced by A1 or this produced by A2? Can you tell me that probability? So from here it will go here. Usual probability goes from this side to this side, from left hand side to right hand side, but Bayes theorem goes from this side to this side. Given defective, don't tell me what is the probability of defective. I'm already telling you this is defective. Given defective, tell me where is it coming from? Is it coming from A1 or is it coming from A2? Where is it coming from? That will be given by Bayes theorem using the formula that we have seen here, which formula is very easy. Let us see how to derive that formula. So overall defect rate is 2.6%, isn't it? In that overall defect rate, there is A1 contribution, A2 contribution. Look at this carefully. A1 contribution is this much. A2 contribution is this much. B given A1, this is A1 defect rate, A1 production. A2 defect rate, A2 production. This is overall defect rate. But right now, we already told the probability of B. Say, I have given one bolt is defective already. I told you today is Saturday. Then I asked you what is the probability of Saturday. What will that be? If I give you a sure shot event and I asked you the probability of it, what will that be? I told you just now today is Saturday and I asked you what is the probability of Saturday. How much that will be? That will be 1, isn't it?
100%.
Yeah, 100% sure shot event. So probability of B, probability of defect. What did we say? We already told it is defect. That means this side is already 1. How do you make this side 1? Divided by probability of B. Divided by probability of B. Divided by probability of B. So 1 is equal to probability of B given A1 into probability of A1 divided by probability of B. This is contribution from A1 plus Contribution from A2 is B given A2 into probability of A2 divided by probability of B. This is contribution from A2. A1 contribution, A2 contribution. This in this 1. Okay. Total equal to A1 contribution plus A2 contribution. This is nothing but the Bayes theorem that you see. Look at this. If we carefully look at the Bayes theorem, probability of A given B, or let me say A1 or A2. B means defective. Given defective, is it coming from A1 or is it coming from A2? Which is equal to probability of B given A. That means A1 defect rate into A1 production divided by overall defect. If I am talking about A2 given B, defective. Given defective, is it coming from A1? Given defective, is it coming from A2? This is the formula. This is the Bayes theorem. But now what we need to do is we need to connect this Bayes theorem to our sentiment analysis. How does sentiment analysis work from this Bayes theorem? Because Bayes theorem in the nuts and bolts and all this thing, it looks fine. Given the bolt is defective, which machine it is coming from, we are getting a probability formula for it. But how do you define the sentiment from there? Here is the final connection. Look at this, all of you. Imagine there are two machines. Machine A1, machine A2. Or let me say machine C1, class 1, machine C2. Let us suppose machine A1 is producing all the positive reviews. Look at this carefully. Machine A1 is producing, or C1 is producing all the positive reviews. Every review that is coming out of C1 is positive, 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 positive. Machine C2 is producing all the negative reviews. C1 is producing positive, C2 is producing negative reviews. Completely negative, 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 negative. Now I have a new review or new document. This is the new document D. Given this new document, now there are so many words in it, there are so many sentences in it. Given this document, can you use Bayes theorem and backtrack? Find out. Tell me, complete the statement. Given this document, using Bayes theorem, what are we going to find out?
We will find out the probability of it.
Coming it from C1 or probability of it coming from C2. Maybe it may come from C1, it may come from C2, whichever probability is higher, we will say that is the final sentiment. Maybe there is a 30% chance that it is coming from C2. There is a 70% chance it is coming from C1. Then we will say it's a positive document. Given D, is it coming from C1 or C2? Probability of D given C1 into probability of C. Let us take a simple example to understand this, how these probabilities are calculated. All these probabilities are calculated totally internally, okay, using some formulas, using the formula, which is an extended form of this. But if we have to manually calculate these formulas with our own hands, because anyway, we know these probabilities, how are they calculated? Let us take one example. Somebody wrote something like in his document, he wrote good only. That's it. There is one review. He simply wrote good and put 2 exclamatory marks. So in the punctuation removal, we removed the exclamatory marks. Good is left. Good. Tell me, is it positive review or negative review? For a human mind, it is simple. We will say this is anyway positive review. But if we have to use Naïve Bayes theorem, how does it calculate probabilities? So that will be probability of D. D is good here. So probability of good, how many times it appeared in positive into probability of positive. How many times it appeared in negative into probability of negative. Let us suppose if we go to our own data set, how does that look like? Let us get those numbers. So this is the overall formula, probability of good in positive, good in negative. Okay. Overall, there are 8582 positive documents, 7871 negative documents. Overall, this is overall. Good has appeared in positive as well as negative. Is it true that good can appear in both the documents? Think about it. Or it will be appearing only in positives always. It can appear in negative also. So it has appeared in negatives as well as positives. Okay. Now to substitute these values, probability of positive, probability of good in positive, given positive, probability of good, given negative, probability of good, all those things we will calculate. Look at this. What is probability of positive? For calculating probability, always first write down the denominator, all the events, then think about the numerator, which is favorable events. Tell me what is probability of positive. In the denominator, how much will you write? Think about it. What is probability of positive in this context? Look at these numbers carefully.
1218. 1218.
In the denominator, how much is this?
Total.
Probability of positive. Tell me how much is it?
8582
8582 plus 7788.
778. Denominator means all the events. Yes or no?
Yes, sir.
Total events. Numerator, what is it?
8582.
8582.
Oh, yeah.
Do you agree? Think about it. Is this right? For any
sir.
given tweet to be probability of positive, overall positives divided by total. Probability of negative, tell me. Probability of negative.
8582 plus 7781.
8582 plus 7781. In the numerator?
7781.
7781.
Now, given positive, giving you prior information. Given positive, what is the probability of good? Given
231 plus
positive,
121.
first of all, tell me the denominator.
8582. 231 plus 121.
231 plus 128.
Given positive, think about it. Given positive,
One,
that
two.
means it means
121.
in the denominator, how many records will be there in the denominator? Given positive,
1218.
let's say 1218. I'm just writing. In the numerator, how many will be there?
Sir,
Given
in
good.
numerator 8582, sir.
Numerator 8582. तब तो ये 4 हो गया ना, 4 और 7 हो गया ना, 6 हो गया.
Sir, the opposite. Sir, the denominator 8582. Sir.
हाँ, think about it. Can probability be more than 1? Now rethink and tell me what is denominator given positive. First think about denominator. Denominator कितना आएगा?
8582.
8582.
5 again
1218.
1218. Numerator में कितना आएगा?
1218 divided by 8.
1218, is it? So denominator will be given positive, which means 8582. Makes sense?
Yes, sir.
Are you convinced with this? Think about it.
Yes,
Numerator में how many are favorable? Within positives, how many times good appeared?
1218 times.
1218. Makes sense? This one, does it make sense? Think about it.
Yes. Yes, sir.
Yes, sir.
Given negative.
7781.
Given negative.
7781.
7781. Numerator?
231.
231. Perfect. Overall good. Doesn't matter positive or negative. Overall good. What is the probability of overall good? Denominator will be what?
1218 plus 231.
1218 plus 231. Okay. Numerator?
Numerator will be overall.
1218
No,
plus
sir.
231. That means good is appearing
sir.
everywhere, is it?
No.
Probability of good
No,
is
sir.
1%, is it? Complete 100%. Is that the case?
No.
Tell me what
No,
are the
sir.
denominator cases? Denominator.
Sir, denominator is 8582
8582
plus 7781,
7781.
isn't it? When you think carefully, no matter whether it is positive or negative, doesn't matter. Complete tweets. In the numerator, it will be
231 plus 128.
2318.
Yes.
Yeah.
1218.
Plus 1218 or only 1218?
Only one to
No,
one.
sir. Both, sir.
Only 18. Why? Think about it.
No, sir. Both, sir.
Why only in positives you are
sir.
taking? What is the
Negative
logic for
comments are
only taking 1 to 18? Is what is
Because
it?
we are
Both are good
looking
only,
for good.
Good. The word
So we have
good,
to take both.
is it appearing only in positives? 1 to 18 only?
Negative,
Negative
also.
also.
So we
These
have to
two-
take both.
Yeah. So does it make sense if it's like 231 plus 1 to 18? But why did I take 1 to 18 here then?
It's
Here,
only
That
why
is
did-
for
only
positive, sir.
Given
Both are
positive.
Given
That was
positive.
given
Is there
positive.
anything
positive.
given here?
No, sir.
Overall.
Overall.
Yeah,
So
overall.
overall, whether it is positive or negative in the numerator, you will write 231 plus 1 to 18, 8582 plus 7781. Do you agree with that point?
Yes, sir.
Yes, sir.
Yes.
So All these calculations that we did, once again, look at this recap. Probability of positive favorable events are 8582 divided by 8582 7718. Makes sense? The same thing that we got. Probability of negative 7781 8582 7781. Are you clear on these two things? Please acknowledge, all of you. Probability of positive, probability of negative.
Yes.
Yeah,
Yes, sir.
these two things are simple,
Yes, sir.
straightforward, isn't it? If there are 100 tweets, 50 are positive, 50 are negative, what will you say? Probability of positive 50 by 100. Yes or no? Probability of negative 50 by 100. Similar to that, what we have done. Probability of good given positive, how many times good has appeared in positive, overall positive in the denominator, good appeared in positive 1218 divided by 8582, 231 divided by 7781. Probability of good overall good, overall documents, isn't it? The same calculations we also concluded. Do you agree? Think about this. These are all correct, isn't it?
Yes.
You just need to think little carefully. Like the given can be sometimes confusing, but overall this is simple counts. When you do this, when you substitute probability of positive here, probability of good in positive here, probability of good here, when you do all these things, this particular, let's say if somebody writes simply good, and that's the only word that it has in a document, then that will have the probability of that document being positive. Finally, it will come as 84 point some percent. And then that being negative, there is a probability of negative as well, some 15.94%. So this finally, if somebody writes good, Naïve Bayes model will call this, what will be the sentiment it will assign finally based on these probabilities? It will be classified as which document?
Positive.
Positive document. Why positive? Higher probability. But that is for
Yeah.
only one word. But what if I have good, this is a pretty good restaurant, I am all happy with it, like that? You have word 1, word 2, word 3, word 4, word k. Usually you will have multiple words, isn't it? The extended formula for Bayes theorem will be probability of word 1 given positive, word 2 given positive, into etc etc, divided probability of word 1, word 2. This is the extended formula for complete multi-word document, which will be the real formula that will be used in the background. Multi-word formula, multi-word real document. This formula will be used for the calculation of the sentiment. But all these calculations, do we get to see them when we are building the model and all that? These calculations will happen in the background. Finally, what Naïve Bayes gives us is whether given a document, whether it is positive, or given a document, whether it is negative. Finally, it will give us this. There is only one thing. Usually, sometimes you will have positive reviews, you will have negative reviews. Sometimes you will have neutral reviews also. Positive, negative, neutral. So in practice, what we should do is take only positive reviews, take only negative reviews, remove neutral reviews. If you keep these neutral reviews, they may create some gray area, isn't it? They may create some confusion to the model, because sometimes a neutral review is near to positive. Sometimes a neutral review is near to negative. Let's say somebody wrote a review, first paragraph positively he has written, next paragraph negatively he has written. Is it possible? I'm finding these things
Yes, sir.
good, I'm finding these things bad. What
No,
will
sir.
model learn from here? Isn't it? So that's why these are problematic. Remove neutral reviews, remove neutral documents. What you should do instead, let's say in future, if a new document, somebody has written positively, somebody has written in the review negatively also, look at the probability. If the probability of positive is in the range of 40 to 60, that means 50-50, 55-45, 40-60, 60-40, then call all these as neutral. If the probability of positive is 70%, then call it as positive. Probability of positive is 30%, then call it as negative. But if it is in the 50-50 range or 40-60 range, then at the time of prediction, you can call it as neutral. But while building the model, you should avoid the neutral tweets or the neutral reviews. So here is the code for building the model. Take the data set, create a document term matrix. There are some neutral tweets in our data set. We have positive, negative, neutral. 3 types of tweets are there. If you go to our data set, this is the data set given here. So let us go to our data set in the code. So here is our data set. In this data set, we have the raw tweet, and then there is one extra column called sentiment label. So this target variable y is there. Neutral is also there here. We will remove neutral and we will keep only positive and negative tweets. Okay. Removing the neutral and working with the rest of the data is what we need to do. Let us look at the code here. Take the Twitter data. In this Twitter data, we have the final sentiment label, raw tweet, text column cleaned, finally cleaned column. So what we are going to do is first take the sentiment label. There are neutral tweets, ignore them. 7781, 858. In fact, the example that you have seen earlier, this whole calculations that we did, it is originally on the real data only, our own data only. We have done all these calculations for the Bayes theorem. It is it. Bayes theorem calculation, it's actually our data only, 8582 7781. So create a document term matrix first. Okay. Once you create a document term matrix, divide the data into train and test data. Take 20% data for testing. Build the Naïve Bayes model. Senti model is multinomial Naïve Bayes model.fit xtrain and ytrain. After building the model, check the accuracy on train data and test data. Usually, a difference of 5 points or near to 5 points is considered as overfitted model. Here, if you see 4 points difference is there. But generally, when it comes to text mining, you cannot expect exactly the same vocabulary being used in train data and test data. The words that are used in the train data and exactly the same words that are used in the test data, we cannot expect the same vocabulary. If it is numerical data, the distribution of the train data, the distribution of the test data will be almost same. That's why we do not allow a little bit of difference between them. Maximum 2-3 points difference we allow. But here in text data, a little bit of overfitting is always expected because the words or the vocabulary may change from train data. The words in train data, the words in test data are slightly different. So that is why even though there is a 4% difference, it is still not considered as overfitting. It is expected. Then on the test data, 20% of the records, these are the predictions. But these are not the predictions that we are generally interested in. What we are interested in this one. Let's say somebody has written a new document. Now that you have built the model, use this model. Awesome experience. Go for it. It's a great place. Very bad day for me. I would like to forget it as soon as possible. These are 2 new tweets. Tell me one thing. Is our model, was it built on tweets data like this? Is it possible for our model to read these tweets and automatically decide the sentiment? What is the input for our model? Is it the tweets or is it the numerical data? Tell me. Do you think our model has the ability to understand these tweets?
No, sir. No,
We
it
have
doesn't
built
need.
the model on what? What is the input for our model? The input is
Numerical data.
what is that name called? What is the name of that
DTM.
numerical? DTM, document term matrix,
DTM.
isn't it? So if you are making a prediction, you have to give the data in the DTM format. Do you agree?
Yes, sir.
Because the input was
Yes, sir.
DTM. So that means if your tweet is like this, so we have given this huge DTM, each column is like term, like in each term here is one column. So if you give like this, the model won't understand. We need to convert this. Tweet 1, convert it into DTM. Tweet 2, convert it into DTM. Let's say somewhere remaining words will be there. Let's say abandon, that will be 0. Above, that will be 0. Somewhere awesome will be there. Put 1. Remaining 0, 0, 0. Somewhere experience will be there. That you will put 1. Somewhere grade will be there. Put 1. Remaining 0, 0, 0. Somewhere place will be there. Put 1. Now can the model understand this DTM? Let's say there are 3000 rows in columns in this DTM, 1 row, 1 by 3000. If I give this, can this model understand? Can our model give the prediction? Now?
Yes.
Now it can give prediction because your DTM is the input. Similarly, very bad day for me. Remaining all, put 0. Somewhere bad will be there, put 1. Remaining all 0. somewhere today will be there, that you have to put one today, and then possible will be there, that you put it as one, like that. Though there are two tweets here. So the DTM, how much was the DTM size, document term matrix size after creating the document term matrix? Check the document term matrix size from the model, from the document term matrix is 3474. That means these two tweets will be converted into what format? It will be a matrix. What matrix we have to give? What
2 by
matrix?
3,
2 by
3, 4, 7.
3, 4. Like how many ever terms are there? 3, 4, 7, 4. This need to be given as input. What if there is a new word? Something like, fantastic is here. Okay. Unfortunately, none of these 3, 4, 7, 4 words has fantastic. Can the model do the prediction for a new word?
No, sir.
Model will not be able to. So you need to drop the new words. Drop the new words. Because that it is almost like 3, 4, 7, 4, x1, x2, and so on, x3, 4, 7, 4 columns are used. But can I use x3, 4, 7, 5 columns? Let's say if you are building a model logistic regression line with 10 variables, can you predict with 11 variables? It's impossible, isn't it? Similarly,
Yes.
if you have this extra word, you have to ignore the extra word, decide the sentiment based on all these only. How do you include all these words? You have to build the model with rich vocabulary. You have to take large data set. If you're taking a smaller data set, then those new words, the model will be, ignoring. We have to write the code to ignore those words. Obviously, when you are filling the document term matrix, the words that are matching, you will put as 1, remaining, you will put as anyway 0. Yeah, looks like someone is about to ask a question. Please go ahead.
Yes, sir. How do we remember that the word is the new one or not? Because
So
we
if
couldn't
the
able to
word
remember.
is already there, 3, 4, 7, 4, like what we will be doing, we will be writing the code to match. Let's say you will take awesome. You match every 3, 4, 7, 4 words, isn't it? Yeah. You fill it
Yes.
as 1. If it is matching. If it is not matching, we'll anyway ignore. Only matching words we'll put as 1, right?
Okay, okay, got it, sir.
Before the prediction, you will prepare this matrix, right? While
Yes.
preparing this matrix, you will check. So basically, here you can write a simple code. Okay. What it will do is it will, find out like every row will be taken, every word will be taken, it will match. And if it is matching one, otherwise it will be like, we don't need to do it like manually. I'm saying like using the code, you're supposed to pass through that. Okay. So build the model, Naïve Bayes model, and then they take these two new tweets. Okay. And then do the spelling correction, all the pre-processing as it is, you will do it. Now what you're doing, you are transforming it into this larger text format here. Okay. Make sure that the new DTM, old DTM have same number of columns. Okay. Here I am checking for the new words. If T for T in column values, are you getting it? The question that you asked, like, how do I get to know whether this is in the columns or not? Here we are checking. So here the count of new words are 0. There are no new words. If there is a new word, it will be found and the length will be given. Finally, the new words will be given and we can ignore them. Anyway, this is kind of extra to check whether the new words are there or not. Okay.
Yes, sir.
Yeah. Sometimes, in some projects, what people do is, let's say, fantastic is a new word. Okay. Fantastic is not there. Something like super is there. Okay. In the vocabulary, super is there. Fantastic is not there. So sometimes what people do is people use nearby synonyms. They find out nearby synonyms and then convert these words into nearby synonyms. For that, we need to use a different package. Okay. Which will check. So what that package will do is, for fantastic, it will get 5, 6 synonyms and it will search for those synonyms to be present in this list or not. If they are present, then fantastic will be considered as that will be converted to that word that is there in our vocabulary. For that, we need to write an extra piece of function on top of this. Okay. If we feel that every word is very much essential for us, okay, in that case. Okay. Then finally we will give this 2 by 3, 4, 7, 4. Is this shape clear, all of you? new DTM shape is 2 by 3474. Is there any doubt in this? Why it says 2 by 3474? Why there are 2 here? Why there is 2 here? What is the reason?
Two new comments.
2 new comments are there. And what is 3474?
Number of words.
Number of words in
Unique
our
word.
document term matrix. Okay. And then give that as the input, model.predict. Awesome experience. Go for it. It's a great place. It's a positive sentiment. Very bad day for me. Today, I would like to forget it as soon as possible. Negative. Like that.
Sir, how the model is understanding whether it is positive or negative? Like, are we like, is it inbuilt?
We are mapping, right? First, apart from the tweet, okay? Apart from the tweet, we also have, let's say, my tummy kind of hurts. There is a label called negative.
We need to map it by
First.
our own.
Yes.
Okay.
First, you need to have this data. So initially, if you remember, we had one discussion, right? Like directly, if you give review data, okay, directly only reviews are provided, okay, as input, then model will not be able to understand. What we need to do is we need to give input as well as this label target also we need to give. The target is sentiment, positive or negative. We need to first have this data. Then the model will be built on this. For the new comments, any number of comments will be able to make the prediction.
Okay.
This is the social media data. The kind of projects in the real life that you will get on sentiment analysis are pretty straightforward. Either you may have social media data, which is like Twitter, or which is like Facebook posts or blog posts or something like that. Or your company may have a product or your client may have a product. Product reviews are there, isn't it? Then you may get product reviews. Or your company may be providing a service to some clients. The clients will give you service-based reviews. So if you can understand this social media, product reviews, and reviews for the service providers, then almost the complete text mining and sentiment analysis is totally complete. That's why what I have done is, apart from this data, I have also added a couple of more data sets for you to practice. The next data set is Amazon data. Amazon is product review data. It will cover all the product reviews. Next data set is Yelp. Yelp is a place in US where some services are provided by Yelp. Okay, some car washers or some kind of lawyers, all type of different services are provided. So this is service reviews data. This is product review data, and we have discussed the social media data. If you cover these three, any of these three projects can be kept on your CV simply. Okay, because it doesn't matter if you say my company gathered some social media data for our product, we have gathered this data, we did this sentiment analysis, that is perfectly fine. Okay. I want you to practice the same thing on this data set as well. The same rules will apply there as well. That is the story of sentiment analysis, which will finally give us, given a particular document, we will get to know whether it is positive or negative. Any final questions on this?